everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is a database design concepts, but the new chapter, or we can say the same chapter, that is chapter number 17, that is the database network architecture. In the last class we have started with this chapter, that is the chapter number 17, as well as the part number 5, that is the system architecture. So let's take a quick review what we have covered in the last class and move to the today's topic or today's session, that is the interconnection of the networks, that is how different networks are interconnected with each other. So let's start with the previous class session. In the last class we have started with chapter number part number 5, that is the system architecture, that is how the system architecture works, what is the main criteria or the system architecture works, that is the system architecture. So whatever the architecture of a database system, that is greatly influenced by the underlying computer system that a system works. So whatever the architecture, whatever the structure that is available in the system, that is known as the system architecture. And there are multiple chapters in this, we can say the part 5, that is chapter number 17, 18, 19, that gives a different overview of the different criteria or different method that will be used in the database system that is running on the server system. And server system is the main computer that is used in the day-to-day scenario, that is used in the multiple functionality of a database that is outlined here. Chapter number 18 describes how various sections of a database in a particular query processing can be implemented, how to use them, how to make them very complicated. Then we have discussed about the chapter number 17, that is the database system architecture, that is what is the architecture that the database system uses, that is what is the criteria that is used in the database architecture. So whatever the architecture of a database system that is influenced by the underlying computer system that is available and on which it runs, in particular by such aspect of a computer architecture as the networking, parallelism and the distribution. So whatever the architecture that is used, whatever the influence that is used, that is underlying by the computer system. Now, what are the various aspects that is used by the computer architecture, such as the networking, parallelism and the distribution? First one says networking of computers allows. So whenever we do the networking, that allows the task to be executed on a server and some tasks to be executed on a client machine. So the division of the multiple network, there is a division of the multiple system that is used, the division of the multiple tasks that is to be executed on a server system and some tasks to be executed on a client systems. This division of work has led to the client server database system. That is there is a client, there is a server that is used. So there will be a client that uses a machine or that provides the request for the services, and the server who provides the services. That is a client server database system. That is a networking that is enabled that the users is using the networking systems. Then parallel processing within a computer that allows the system or database system activities to be speed up. So whenever we use the parallel system, parallel processing, that is more than one process, more than one task will be assigned at or more than one task will be doing at the same time, that is a parallel processing within a computer system. So it speed up the task of the transaction that is doing in the transaction basis. The need for the parallel query processing has led to the parallel database systems. The next point is distributing data across sites in an organization allows those data to reside when they are generated or most needed. So whatever the data they are applying, whatever the requirement they are applied, they are applying for the database system that will be accessible from the other sites and the other departments. So distributed database system handles geographically or administratively distributed data spread across the multiple database systems. Then we will discuss about what is the main difference between the centralized and the client server architecture. So whenever we say that centralized, that means every database is connected or every database is combined into the one place that is available at the one place. That is a centralized system. That is every data is available on a single computer and that does not interact with the other computer. That is a centralized computer. And the client server means client requests for the services and server provides the services that is requested by the clients. Such database system span a range from single user running on a personal computer to the high performance database system running on a high end server system. So it works from the personal computer, it goes to the high end server system. Client server system, on the other hand, we are frequently split up between the server system and the multiple client machines. There will be multiple client machine, there will be a server system that is available in the database systems. So then we will discuss about the centralized system. That is, what is the centralized system, what is the usage of centralized system, why we are using the centralized system, what is the main benefit of centralized system. So, a modern general purpose computer system consists of few or more processor and number of device controller that are connected through a common bus that provides access to a shared memory. So, whatever the shared memory that is used by the server systems. And we differentiate between the single user system and the multi-user system, by which we can apply the changes, by which we can do the changes, by which we can make the change in the database system. Multi-user means more than one user is using at the same time. This is a centralized system. There is one memory, one space that is available, and there are multiple parts like CPU, disk controller, USB controller, and the graphics adapter. These are the various parts that is available in the database systems. So this is the CPU, this is the disk controller, USB controller, graphics adapter. These are the various disk, mouse, keyboard, printer, and the monitor. Although most general purpose computer system in use today have multiple processors, they have cores, granularity, parallelism. So whatever the general purpose computer that is using, they are using the computer in a general purpose mechanism with only the few processors that is available in that shares the main memory that processes the same memory. Database designed for a single processor machine already provides multitasking. So whatever the machine, whatever the single tasking also provide the single machine. Then we have talked about the client server system. The same method, client request for the services from the server. Server in turn takes the request from the client, make the processing and performs and gives the, we can say, the provide the services to the client. That is a client server system. As a result, centralized system today acts as a server systems that satisfy the request that is generated by the client system. Functionality that is provided by the database system can be broadly divided into two parts. There are two parts that is divided into two parts. One is the front end, one is the back end. And for back end means that is not available, that is not visible to the users, but every work is doing at the back end. Front end means everything is available or displayed to at the front end. So this is the general purpose client server machine. There will be one server. This is the network. These are the multiple client that is available. The next is the server system architecture. That is how to use the server system architecture. What is the main categories by which the server system can be divided? So these are divided into two parts. One is the transaction server. One is the data server. And this is available at the front end. I'm so sorry. And this is available at the back end. And this is the interface between the front end and the back end. Also, there is a transaction server system, also known as a query server system, that provides an interface to which the clients can send the request to perform an action, in response to which they executes the action and sends back the result to the client. So whatever the request that is supplied to the client, whatever the request that is supplied to the client, that is available at the server systems. Usually client machines ship transactions to the server systems where those transactions are executed and the results are shipped back to the clients that are in charge of displaying the data. So whatever the data that is available, whatever the point that is available, that is displayed in the database systems. Then there will be a data server system that allows the client to interact with the servers by making requests to read or update the data, such as the files or the pages. So whatever the data that is available in the, or that is displayed in the files or the pages. Of these, the transaction server architecture is the most widely used architecture that is available. The next is a transaction server. So whatever the transaction server system that is using the multiprocessing that handles the data in the shared memory, that is the transaction servers. And the processes that forms part of the database system includes the server processes, then log manager process, then database writer process, then the log writer process. So these are the various processes that is available in the memory, that is available by the transaction server. And these are the various checkpointing that is used, that is ODBC, JDBC that is available. Then we have talked about the data server, that is what are the data servers, or what are the various servers that contains the data or that provides the data, that are known as the data servers. So whatever the client machine, whatever the data that is available in the database systems. Data server architecture have been particularly used in the object-oriented database system. So it is used in the object-oriented database system, that is used as a, or that takes the object and makes the necessary changes that is available in the database system. And there is a page shipping, that means we can apply the architecture, data caching, log checking. These are the various mechanisms. Then we also talked about the cloud-based server, that is what is the meaning of the cloud computing that is used in the day-to-day scenario, where very we can say the it is increasing demand in the day-to-day basis, that is a cloud-based server, that is a cloud computing, in which there is a third-party server that is used, that is a cloud computing, in which the service provider runs in its own software. That is a server provides its own software that provides the services in the form of the cloud computing or cloud computing. And there will be virtual machine that is available, available as a simulated machine, that is available as a service provided. Then there will be a third model that uses a cloud computing service, that as a data server, such as the cloud-based data storage system, that is covered in detail in section 19.9. Then there will be a parallel system that we have discussed, that improves the processing and input-output speed by using the multiple processors and disk in parallel. So whenever we use the parallel system, that means more than one system is using, or more than one task is executing on a multiple system. That is a parallel system. That is task is executing at the parallelly. That is two systems uses the or we can say the apply, or we can say the changes, or we can say the use the same task on a continuous basis. That is a parallel system. That is a multiple processor and the disk are using in the parallel. Parallel machines are becoming increasingly common, and managing and making the study of parallel database system correspondingly more important. In parallel processing, many operations are performed simultaneously. That is, there are many operations that is performed in a simultaneously. That is a parallel system. There are two main measures of the performance of a database system by which we can perform the measurement of a database system. One is the throughput, one is the response time. The throughput means the output that is available, that is the throughput, that is how many tasks that can be completed at a given time interval, that is the throughput. And the response time means how much time is complete, or how much time is taken to complete a given task, that is the response time. So one is the throughput, one is the response time. Then there will be a speed up, that means how the data will be available in the speed up. That is, there are two different issues that is available. One is the speed up, one is the scale up. So whenever we increase the task in a less time, that is more than one task is applied in a less time, that is a speed up. And how to handle them by increasing the parallelism, that is a scale up. So one is the speed up, one is the scale up. This is the linear speed up and the linear scale up. These are the various ghosts. Now next is the interconnection network, that is today's topic. So this is how to interconnect the various network, how various networks are interconnected with each other. So parallel system consists of the set of the components. So there are multiple components that is available, such as the processors, memory, disk, that is available, that can communicate with each other via interconnection network or via interconnected network. So there will be a network that is available, that is the interconnected network. By this interconnected network, the parallel system may work, or the parallel system can done or can perform the operation that is used in the parallel computing, that is the interconnection network. So first type of or figure 17.7 that is available, that shows the three commonly used type of network, interconnecting network, that is available. This is the three types of interconnection network, that is how differently the different connections are interconnected with each other. First is the bus. There will be a serial bus by which different computers are connected with each other, that is a bus. Then next is the mesh. Mesh means one computer is connected to another, another is connected to another, another is connected to another. That is a mesh. Then there will be hypercube. That is a cube will be maintained. One is connected to the another, another is connected to the another, and so on till the then the hypercube will be maintained. First is the bus. All the system connected can send the data or receive from a single communication bus. This is a single communication bus that is available. That's why it is saying bus. The mesh, the components are nodes in a grid. So these are the various components that is available in a grid, and each component connects to all its adjacent component in the grid. So whatever the component that is available in these 6 or 7 or 8 grids. This connects the 6 adjacent sites. These are the different sites that is connected with each other. Then there will be a hypercube, that is components and number in the binary. So this is available in the binary term, that is different codes are available in the binary code. That is, and each component is connected to one another with the binary representation with the different nodes that is available. They can different in the exactly the 1 bit. So they are different in the 1 bit. So these are the various interconnected nodes, that is how the various nodes are interconnected with each other, or we can say how different computers are interconnected with each other via interconnected network. These are the three methods by which the we can say parallel computing can be done. One is a mesh, then there will be a bus, then there will be a hybrid or hypercube or hybrid. Next is the parallel database architecture. That is, what is the architecture that is used for the parallel database system? So there are multiple architectures. There are several architecture models that is available for the parallel systems or parallel machines. Amongst the most prominent one that is available in the figure 17.8. These are the various parallel database system architecture that is available. One is a shared memory, then shared disk, then shared nothing, then there will be a hierarchical. So first is shared memory, that is all the processors have or share a common memory. So whatever the memory that is available, every processor shares a common memory that is available. So there will be one memory space, and that memory will be shared by multiple users, multiple clients, multiple parallel systems. That is a shared memory. Then there will be a shared disk, that is all the processors that have a common set of disks that is available. They are sometimes also known as the clusters. Then shared nothing, that is a processor do not have any common thing that is used for the common disk. Then there will be hierarchical, that is a hybrid of the preceding three architecture that is available. These are the various 4 types of memory, that is the shared and the disk, memory, shared nothing, and the hierarchical. Techniques that are used to speed up the transaction processing on data server systems, such as the disk or data and the log caching and log disk acceleration, can be used in the shared disk parallel databases as well in the shared nothing parallel disk database system. So it is available in the multiple system, it is available in the database systems. Then next is the shared memory. So in our shared memory architecture, the processors and the disk have access to common memory, typically via a bus. So whatever the shared memory that is available, that interconnection will be maintained via communication channel, that is a bus, by which or that is an interconnected network by which different computers are connected with each other. That is a shared memory architecture. What are the base benefit that is available for shared memory? That is, it provides a efficient communication between the processors. That is, data may be shared or data may be communicated with very efficiently and effectively whenever we use the shared memory with the use of the communication bus. A processor can send the messages to other processors much faster by using the memory, right? So whatever the processor that is used that can send the messages to other processors much faster way by using the memory rights. Adding more processes does not help more points in the processor will speed up or take most of the time that is available in the shared memory. Then there will be a shared disk, that is there will be a disk that is shared among the various processor, various nodes. So in a shared disk model, all the processor can access all the disk directly. So whatever the processor that is available, whatever the CPU that is available, they can access all the disk directly via an interconnected network. So by using the interconnected network, they are distributed among each other. But the processors have private memory. So there are different memory that is available, that is processed by the different processor. That they have a different memory that is available in the database access. And there are two advantages that is available over shared memory that is used. That is available in the different memory that is used by which we can access the data, by which we can take the data. But So there will be a shared disk that is available that processes the data in a shared manner. That is a shared disk that is available in the fault tolerance, that is available, that is used for the various capacities, that is used in the RAID system, that is a redundant array of independent disk. The shared disk architecture has found the acceptance in many applications. So whenever we use the shared application, whenever we use the shared memory application, that will be used for the various application that is used in the scalability. But the main issue is that the main problem with the shared disk memory is that there will be scalability. That is the system will be scaled with each other. That is, a bus is or memory bus is no longer a bottleneck. The interconnection will be used, that is available in the database systems. So this is so that is available in a scalable system that is used with the bottleneck, that is the interconnection of this system, that is now bottleneck, that is available in the situations where the database makes a large number of access to the disk. Then next is a shared nothing, in which each node of the machine consists of a processor, memory, and one or more disks. So that means every node that is available of the machine that consists of the processor, that is a CPU, that is then the memory, and one or more disk that is available in the shared nothing systems. So each node contains various processors, memory, and the one or more disks. The processors at one node may communicate with another processor at another node by a high-speed interconnection network. So there are different processors that is available. They can communicate with another processor at another node by a high-speed interconnection network. A node functions as the server for the data on the disk or the disk that the node owns. So whatever the node function that is used, that is used by the server system that is available in the database access. The main drawback of the shared nothing system. So what is the main limitation of shared nothing system? That is, there are different cost of communication and of non-local disk access that is available, which are higher than the in the shared memory and or the shared disk architecture, since sending data involves software interaction at both the ends. So whatever the software interaction that is available at both the ends. Then there will be hierarchical architecture that combines the characteristics of the shared memory, shared disk, and the shared nothing architecture. So in the hierarchical structure that combines, there are various characteristics that combine the characteristics of the shared memory, shared disks, and the shared nothing architecture. So it combines all the architecture that is available, that is the shared memory architecture, that is the shared disk architecture, and the shared nothing architecture. At the top level, the system consists of the nodes that are connected by an interconnection network and do not share the disk or the memory with one another. So these are the various systems that consist of the node that consist of the various data that is available, that is connected by the network and do not have access to the network that is available with the interconnected networks. Therefore, the top level is a shared nothing architecture, and each node of the system could actually be a shared memory system with a few processors. Alternatively, each node could be a shared disk system, and each of the systems sharing a set of disks should be a shared memory system that is available in the database system. Therefore, a system could be built as a hierarchy, that is, they are available as a hierarchy with multiple levels of the system, that is a shared nothing system, shared capacity system, shared memory system that is available in the hierarchical manner. And where there are various attempts to reduce the complexity that is available in the shared system, that is yielded in the distributed virtual memory architecture. So whatever distributed architecture that is available, they yielded a high yield virtual memory architecture. So since access speed differ depending on whether the page is available locally or not, such architecture is referred to as a non-uniform memory architecture. That is a non-uniform memory architecture, that is a NUMA. So that is available in the distributed virtual memory that is available in the different speeds. Then next is a distributed system. So that is the next system, that is a distributed system. So we have covered with the client server architecture, we have covered with the parallel system, and we have covered with the distributed system. So in a distributed database system, the database is stored on a several computers. So whatever the database that is stored, whatever the database, whatever the content for that, whatever the records that is available, that is stored on the several computers. The computers in a distributed system communicate with one another through various communication media. So whatever the computer that is available that are interconnected with each other, that are interconnected in a distributed system through the various communication channel, such as the high-speed private network or the internet. So whenever we use the distributed system, that means more than one computers or more than one database is shared among the several computers. And computers are distributed in distributed systems, and computers in a distributed system communicate with one another through various communication media. So there are different communication media by which they are connected with each other. Either they are connected with the private network, that is the intranet, either they are connected with the internet, that is the publicly owned network, and they do not share the main memory or the disk. The computers in a distributed system may vary in size and function, ranging from workstation up to the mainframe computer. So whatever the distributed system that is available, they are different from size to function, they are different from the part to the function, and they are ranging from workstation up to the mainframe computer. That is, the workstation means that it can be connected to a network, and the mainframe means whatever the system that is available for the interconnection of the network. The computers in a distributed system are referred by a number of different names, such as the sites or the nodes. So whatever the system that is, or whatever the computer that is available in the distributed system, that is available or that is referred by a number of different names, such as the sites or the nodes, that depends on the content that is by which it is defined. And we generally use the term site to emphasize the physical distribution of these systems. And there will be a local transaction that is accessed only from the sites where the transaction was initiated, and there will be a global transaction that is available by which we can access the data in a site from the one another site that will be available from the other sites also. This is the network. This is the site A, this is the site C, this is the site B. This is the distributed network. That is a different sites may communicate with each other via the communication channel, via the wire or via the line that is available in the database system. So there is a site A, there is a site B, there is a site C, and in between there is a network. That is a communication via the network. So there are several reasons for building the distributed database systems, including sharing of data, autonomy, and the availability. So there are multiple reasons by which we can distribute the, or by which we can build the distributed database system that is available. That includes how to share the data, then autonomy, and the availability. So first is sharing of data. That is, the distributed data system must be maintained, or must be, we can say, the structured or architect in a such a way that there will be a sharing of data among the various systems, among the various database users. That is, every user is we can say it's attracted or is getting the data that is shared by the multiple database system that is available in the distributed system. For example, in a distributed university system where each campus stores data related to that campus, it is possible for a user in one campus to access the data in another campus. So it is possible that the data will be available from one campus to the another campus. That is a sharing of the data. Because the data is shared, data is distributed among the various concern among the various universities. Then there will be autonomy. That is the primary advantage that is used in the sharing data by means of the data distribution is that each site is able to retain a degree of the control over data. So whatever the control that is available, there will be a degree of control that is available on the data, and each site has to maintain a degree of control that is stored on the locally or that is stored in the database system. In a centralized system, the database administrator of the center site controls the database. In a distributed system, there is a global database administrator that is responsible for the entire system. So whatever the data that is available, whatever the control that is available in the distributed system. A part of these responsibilities is delegated to the local database administrator for each site. So depending on the design of the database system, distributed database system, each admin user, each administrator may have a different degree of local autonomy. So it depends on the local autonomy. What is the main concern? What is the main data that is available in the autonomy for the distributed systems? So possibility of local autonomy is often a major advantage of the distributed system. Then there will be a availability, that the data will be available at more than one places. So in a distributed system, that same data will be available at more than one places. So there will be a data that is available. So if one of the site, if one of the network, if one of the system fails, so data will be accessible, data will be taken from another system, because every system contains a copy of the data, because every system is in a distributed database system. So the data will be available. So in case of failure of a site, that does not necessarily imply the shutdown of the system, because if any site fails, then we can retain the data from another site. The failure of one side must be detected by the system and the appropriate action may be taken to recover from the failure. So proper action will be taken to recover from the failure. The system must no longer use the services of a failed site. So the failed site that is available, that is no longer in use, we can use the system from the new site because the same data is available to the new site or the different site also. This is one of the example that is used for the distributed system. So consider a banking system that consists of 4 branches in 4 different cities. So there will be a bank that is available in the 4 branches in 4 different cities. Each branch has its own computer with a database of all the accounts maintained by that branch. So that every branch, every city has different computers, have a separate computer by which we can maintain their data. Each such installation is a site. That is, every computer that is available is a site. There also exists one single site that maintains information about all the branches of the bank. Suppose if I am talking about any bank that is available in the 4 sites, so there will be one database system that is a distributed system that is available, that contains the data, that contains the information of all the branches of the bank. So illustrates the difference between the two types of transaction, local and the global. Consider a transaction that is used to add the $50 to the account number, that is A177 locality at the Valley View branch. If the transaction was initiated at the Valley View branch, it is considered local. Otherwise, it is considered global. So if I am going to the same branch or the same bank or the same locality bank in which my account is performed or my account operates, that is a local transaction. Otherwise, it is a global transaction. A transaction is to transfer $50 from account A177 to account A305, which is located at the hillside branch. That is a global transaction. From one state or one city to another state or on one branch to another branch, that is a global transaction. Since accounts in 2 different sites are accessed as a result of its execution. Then implementation issues, that is, what are the various implementation issues that is available in a distributed system. So atomicity of the transaction is important issue in building a distributed system. So what is the important issue that is available? That is the atomicity. That is, the data will not atomic as per the distributed database guidelines. So if a transaction runs across 2 sites, unless the system designers are careful, it may commit at one site and abort at another site. That is, if the system designers are not concerned about the database or distributed database system, then there will be updation on only one site, and then another site does not contain the updation. That will creates a gap between the 2 transactions, between the 2, we can say, the distributed system. So same data is not available from the distributed system. So this is one of the major concern issue, is that there will be a less atomicity, that is, the data is not updated at a regular basis on all the computers at the same time. So it must be updated at all the computers at the same time with a different or with a given resources. Then two-phase commit protocol that is available, that is the most widely used protocol that is used. And the main motto behind the two-phase commit protocol is that for each site to execute the transaction until it enters a partially committed state. So this will be available to execute the transaction to enter the partially committed state and leave the commit decision to a single coordinator site. The transaction is set to be the ready state at the site at this point. Now another issue that is available is the concurrency control. That is, if there are more than one data that is available in more than one computer in a distributed system, so there will be a less concurrency among them. So there will be a control at the starting phase. It is a prevention measure that there will be a control in the concurrency in the distributed system. Therefore, a deadlock detection needs to be carried out across the multiple sites. The standard transaction model that is based on the multiple action that is also carried out by the single development cost. And in case the organization has chosen between the distributed and the centralized architecture, so what are the various criteria by which, what are the various complexities that is, we can say, the differentiate between the distributed architecture and the client centralized architecture. That is, at one place every data is available. Distributed means data is distributed among various sites, among various computers. So first one is the software development cost. It is more difficult to implement a software distributed database system because it is too costly. So one of the main concern is that whenever we implement distributed database system, that is a costly issue. Then greater potential for the bugs. That is, a distributed system have a more error prone as compared to the centralized system. Then increased processing overheads, that is also an issue. Now next is the network types, that is what are the various types of network that is available. So let's stop over here only. Now let's take a break, then move to this topic, that is the network types. Now the next topic is network types, that is what are the various types of network that is available. So there are generally three types of network that is available, then that is LAN, WAN and the MAN. But in this book there are only two network that is available, that is the LAN and the WAN, that is the local area network and the wide area network. So distributed databases and the client server systems are built around communication network. So whatever the communication network that is available, so that is built on the communication network. There are basically two types of network that is available. One is a LAN, that is a local area network. One is a wide area network. And the main difference between the two is the way in which they are distributed geographically. That is, there is a difference between them, that is they are distributed geographically. That is, local area network means a network within a boundary, and the wide area network, that means a network beyond the boundary, beyond the geographical boundary, that is a WAN. In a WAN, on the other hand, a number of autonomous processors are distributed among the various large geographical area, that is a WAN. This is the gateway that is used. This is the local area network. This is the printer, laptop, file server that are connected with the gateway. There will be application server, workstation. These are the different computers. This is the server that is used. So first is a local area network, that means a network in which the area covered, that is a locally, that is a we can say the within the geographical boundary, that is a local area network that is used by which we can people recognize for their enterprises numerous small computers, each of which have multiple self-contained applications that are economical than a single large system. That is a LAN is very full-fledged system, that is very cheap system, that is very we can say not the costly system, and it is used to implement small component the peripheral devices such as the disk and the printers, and there are data sharing is very we can say the important in the local area networks. And LANs are generally used in the office environment, that is it is generally used in the office environment. And there will be a SAN also, that is a storage area network. It is a special type of high-speed local area network that is designed to connect large banks of storage devices to computer that uses the data. So whenever we combine multiple storage devices, multiple storage network, that is known as the SAN, that is storage area network. This is the example of the SAN. This is the SAN, this is the storage array, this is the storage array, then this is the tape library, server data processing. Next is a WAN, that is a local wide area network. This is the beyond the geographical boundary. For example, the internet. Whenever we use the internet, that is a WAN, that is a wide area network in which we can send the data to another country, to another department, to another world also. That is a WAN. So that is used by using the internet. There is a DSL line that is used, that is a digital subscriber line that is used for the database connection. In addition to the limits on data rates, communication in the WAN must also be centered with the different latency that is used. And WAN can also be divided into two parts. There will be a discontinuous connection, there will be a continuous connection. WAN, such as those based on the mobile wireless connections, hosts are connected to the network only part of the time. In the continuous connection, that is a wired connection, that is connected to the network at all the times. Continuous means a wired connection, discontinuous means whenever there is a requirement we can connect, that is a wireless network, that is a discontinuous connection. Then winding up this chapter, this is a summary of this chapter. First point says centralized database system runs only on a single computer. Then there will be a server that is used for the sending the data, that is a transaction server, data server, by which we can send the data, that is usage of the data server for providing database services. Then transaction servers, data server systems. Then there will be a parallel database system that consists of multiple processors and multiple disks that is connected by a fast interconnection network. Then parallel database architecture, that includes the shared memory, shared disk. Then distributed database system, that is a collection of partially independent database system. Then local area network that connects the nodes that are distributed over small geographical areas such as the single building or few adjacent buildings. Then storage area network, that is a special type of local area network that is designed in a distributed system. These are the few topics that we have covered in this book, in this chapter notebook. These are the various review terms questions, these are the practice exercise questions. This is the bibliographic notes. Now next is the chapter number 18, that is the parallel database. Now in detail we will study that is what is the database system, how the database system will works. So this chapter I'm going to start in the next class, that is in tomorrow's class. So that's all for today's session. Thank you so much everyone for listening me. And if there is any doubts, any suggestions, any queries, you can ask the doubts from me. Thanks a lot everyone. Bye bye.